Hello everyone. In this video we're going to be solving a nice exponential equation with real numbers. We have x minus 1 multiplied by e to the power x squared minus 2x equals 1, and we're going to be solving for x values. Well, I said real numbers, but you can also look at complex solutions if there are any, but the main focus of this channel is real numbers and equations and calculus and stuff like that. If you're interested in complex numbers, I have another channel called aplusbi. Go ahead and check it out. Now, to be able to solve this problem, obviously, the very first thing we usually do is test out some values. For example, can x be 0? Can x be 1? Can x be something else, right? You plug it in, and if that works, great, and you get a solution. If that doesn't work, that's fine, you try another one. But trial and error is kind of like a problem-solving approach, but that's not very concrete or rigorous. I know some people don't even consider that a problem-solving strategy, but I think it's a good strategy, at least if you don't have any ideas. Or sometimes you solve a simpler problem that gives you an idea, and then you can apply it to a different case. Anyway, so for this problem, for example, if x is equal to 0, is that going to work? We're going to get 0 minus 1, which is negative 1, multiplied by e to the power 0 minus 0, which is 0. Unfortunately, e to the 0 is 1, so this becomes negative 1 and does not equal positive 1. So x equals 0 does not work, but at least we tried, right? What about x equals 1? Well, x equals 1 is actually very problematic because it'll make the left-hand side 0, thereby we're not going to get anything from there. Okay? So we tried a couple values. Obviously, I don't want to hit the target here. We're going to save it for the last. Okay? So let's go ahead and take a look at another angle. So how do we solve a problem like this? Well, first of all, something to realize. How many solutions can there be, right? How do you know? Well, if we can tell whether the function on the left-hand side is increasing or decreasing, then we can say something about it, right? Because if you have, let's say, a decreasing function, it intersects the horizontal line only once. Same thing goes for increasing functions. But how can you tell? Well, let's go ahead and call this f of x, a function, and look at the derivative. So f of x is equal to x minus 1 multiplied by e to the power x squared minus 2x. Now we're going to go ahead and differentiate it, because if the derivative is positive, that means all the tangent lines that are drawn to the graph are positive, which means our graph is increasing. I mean, that doesn't necessarily mean it's concave up, but I just gave you an example. It could also be concave down, because concavity is about second derivative, right? So get the idea, hopefully. If not, that's okay, don't worry about it. So how do you differentiate this? It's a product, so we're going to use the product rule. The derivative of x minus 1 multiplied by the second function, plus the derivative of the second function, which is the same function, multiplied by the derivative of the inside, which is 2x minus 2 from chain rule, multiplied by x minus 1, which is the first function. U prime v plus v prime u. That's the product rule. Let's go ahead and simplify this a little bit. How do we do that? We have e to the power x squared minus x, so why don't we factor it out? We get 1 from here. These two are multiplied, and when those two things are multiplied, this is very important, you get 2 times x minus 1, but x minus 1 is repeated, so you get 2 times x minus 1 squared. Now this is important. You know why? Because this cannot be negative, and this can't be 0. Or in other words, this is always positive. And since e to the power something is also always positive, can't even be 0, the first derivative is always positive. You know what that means? That means f of x is always increasing. Why always? Because regardless of the x values, it's increasing. Makes sense? X is a real number, f is increasing. Great. So we know that we have one solution. So if we can find that solution, wouldn't that be awesome? Yes, and that's what we're going to do in the next few minutes. Ready? Okay, let's take a look. So x minus 1 multiplied by e to the power x squared minus 2x. And I think I made a similar problem. If I can find the link, if I don't forget, I'll share it with you. If somebody can find it for me, that would be awesome. Sometimes I can't even find the link because I have so many videos. Because I have another channel called aplusbi. I also have a shorts channel, too many videos, right? That's why I kind of changed the schedule. Hopefully you're able to follow. You're going to get 7 videos per week, but 4 of them are going to be from this channel, SyberMath, Cyber with an S, by the way, if you didn't notice. And then the other 3 will be aplusbi, and of course you will be getting some shorts and other videos too. Anyways, so hopefully this makes sense to you. I didn't want to, I was publishing more than once per day, and that was just crazy and undoable. So I had to kind of slow down. I hope you don't mind. Now, to be able to solve this equation, we're going to pay attention to one thing, and that is the relationship between x minus 1 and x squared minus 2x. What are you talking about? Well, if I factor this, I get x times x minus 2. So they're not even related. Yes, they are. You know what? The average of these two things is x minus 1. So x minus 1 is in the middle. You know what that means? If you add 1 to this, you get a perfect square. Why? Because this becomes x minus 1 squared. Wait a minute. Can you just add 1 to the exponent? No, but you can multiply by something. So here's the thing we're going to do. First, we're going to square this expression. Okay? Let's square both sides. And you'll see in a little bit why. When I square, the right-hand side doesn't change, but this does change. And of course, this does change too. I just bring in an extra 2 here, but that, don't worry about it. We'll take care of that. So now we have 1 on the right-hand side still. But look at this. X minus 1 squared is x squared minus 2x plus 1. And I'm super close to that because now I have 2x squared minus 4x. Nice. Well, this could still be that. Maybe I could just leave it like that because I'm about to do something. You know what I'm going to do? I'm going to multiply both sides by e to the power 2. And that'll give me e to the power 2 on the right-hand side. Why am I doing this? Let me show you. I'm going to go ahead and write this down. And now here, we're going to get 2 times the quantity x squared minus 2x plus 1. Because I took the 2 out, I can just write the 1 inside so that when I distribute, I get e squared. You get the idea? Hopefully, that shouldn't be too hard. Now take a look at this. Take a good look. If I multiply both sides by 2, I get something nice. What is that thing? Let me tell you. It is all about a very, very special function called, guess what? Lambert's W function. So whenever you have a structure like this, a form like this, like t to the t equals a constant c, you can apply Lambert's W function, and that'll give you a good result. Because if your input is t to the t, then your output would be t. How nice. Okay, WC didn't sit well with me, but anyways, you get the idea. So here's the thing. We're going to apply Lambert's W function on both sides, and that'll give us Lambert's W of 2 times x squared minus 2x plus 1 times e to the power 2 times x squared minus 2x plus 1 equals W of 2 times e to the second power. Here, we're going to get our t, which is this, 2 times x squared minus 2x plus 1. And here we're going to get our c, which is 2. Awesome. What does that mean? It means that we can write this as x minus 1 squared now and divide both sides by 2. We're going to get x minus 1 squared equals 1. Of course, this has 2 solutions. X minus 1 can be 1, which means x is equal to 2. Or x minus 1 can be negative 1, which means x is equal to 0. Uh-oh. We already know that x equals 0 does not satisfy the original equation. That just came up kind of like an extraneous solution. But x equals 2 does work. Because if you look at the original problem, go ahead and check back with the original equation. If x is 2, 2 minus 1, e to the power 0 is equal to 1. Yes, it checks. So x equals 2 is a good solution. Let me go ahead and show you a graph of this function. So you'll be hopefully more convinced about the solution that we found. Ta-da! Yes, we have an increasing function, and it intersects y equals 1 at a single point, which is at x equals 2. X equals 2, therefore x equals 2 is the only solution. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.